today we're going to have a look at the circle and how symmetry in a circle can help us find missing angles and missing lengths. Now, a lot of the circle work, although it is looking at the circle, is really looking at the triangle, because we can make triangles inside circles, and because of the properties of the circles, we can make isosceles triangles and we can make right-angled triangles as well. Okay, so having a look at this diagram here. In this circle here, just get my pen working, we've got the line DC, which goes through the centre of the circle and it goes from one side to the other. So it is a diameter. If we look at O to A, O to B and O to C, they all go from the centre of the circle to the edge of the circle. So they're all a radius. Because that's a radius, I can highlight this for you, this triangle here must be isosceles. And it must be isosceles because OA and OB are both radius of the circle, so they must both be the same length. Okay. The line AB, which goes from here to here, is called a chord. It goes from any 2 points on the circle, not through the centre. That gives you a chord of the circle. Any straight line joining 2 parts on the circumference is your chord. Any radius is going to cut that exactly in half, because every radius, or every diameter I should say, forms a line of symmetry in a circle. So this line here, line DC, is a line of symmetry. Okay. A perpendicular bisector is a line that cuts another in half and does so at right angles. Now that's something that you'd be more interested in if you want to do higher next year. Because this is at right angles here, we can say that OA is perpendicular bisector of the chord AB. Okay, let's try a couple of examples then. First one, we want to find the size of angles A, B and C. I'm looking at the first one here. Angle A is in a triangle, so we've got 40 degrees, right angle which is 90 degrees, and we've got A, so if we do 90 add 40, we get 130. Angles in a triangle add up to 180. In case you've forgotten that one, angles in a triangle, you've got 180 degrees when we add all three together. So all three angles will be 180. These two add together to give 130. So angle A must be 50 degrees. Now angle B, if you think back to what we said before, here we have a line of symmetry, straight down the middle because it's made up from a diameter. So angle B must be the exact same as angle A. So angle B is also 50 degrees, and similarly angle C must be the same as the one in the same place, so it's also going to be 40 degrees. Okay. Second example, calculate the size of all the angles. Okay, so we've got I, J, K, L, M, N, no, we've got G. Now we've got G. Right, we've got G, H, I, J, K, L, M, N and O. Right, looking at the first one then. So if we're looking at G, these two must be the same. They're in the same place. So that angle there must be the same as this one here. So G is going to be 28 degrees. H is in a triangle here. So that's 90, that's 28. So 180 minus 90 minus 28. I should give myself more room here. It's a good thing about doing it like this, I can just rub it out. Which would be 90, 90 minus 28 would be 62. If I can add up this late at night. Yes, 62 degrees for H. I then. I is going to be the exact same as H, so that's also going to be 62 degrees. J, we're looking at another property of angles here, one that you should hopefully know. Angles along a straight line add up to 180, So these two angles here, J and H, must add up to 180. So to get J, we're doing 180, take away 62. (180) take away 62, that would be 118 degrees. Keep going. L, this one down here. Get a bit trickier now. Right, we know that this angle here is 118 degrees. Okay, this triangle here, I'll just highlight the triangle I'm talking about just now. So this triangle here, it's quite thick, that highlighter. Yeah, there we go. This triangle here is isosceles. That goes from the centre to the edge. That line also goes from the centre to the edge. So these two angles, M and L, must be the same. So to work out M and L, because it will work out both of them, we need to do 180 minus the 118, which takes us back to the 62 degrees, and you'll find this happens a lot when you're doing this. That's shared equally between L and M, so we need to divide it by 2. So L is 31 degrees, and M is also 31 degrees. N is also 31 degrees, and O is also 31 degrees. And for those of you that are good with your alphabet, you'll have spotted I've missed out K. K is the same as J, because it's a line of symmetry, so it would also be 118 degrees. Okay, we're going to calculate D in each of these diagrams then. You might want to, at this point, pause the video and try some of the questions just on angles, or if you think that was straightforward enough, you can keep going and have a look at this as well, and just try both at the same time. So we've got here a right-angled triangle. We've got that that's 7.5, that's 6. We want to find the length of D. Whenever you have a right-angled triangle, you know 2 of the sides, and you want to find the third side, you want to use, and I hope you're shouting Pythagoras at your screen right now. Okay, so first thing we need to decide is, are we finding a longer side, or are we finding a shorter side? Here's my right angle. Right angle always points to the longest side, so I know my longest side. So I am finding a shorter side. If I'm finding a shorter side, I subtract. So we're doing 7.5 squared minus 6 squared. I need a calculator. Let me just get my calculator. Oh, so you can see it. There we go. So 7.5 squared. That didn't work very well, did it? Try that again. 7.5 squared minus 6 squared is 20.25. That's D squared. I want to know D, so I need to take the square root. Which is 4.5, and whenever we're asked anything with lengths, if there's units in the question, make sure the same units are used in your answer. So D is 4.5 centimetres. Second one, I want to calculate D this time. This time if I draw a line or an arrow, points to the D, so I'm finding the longest side. So I want to square and add. If I look at this part here, the full length is 12. As ever, diameter is a line of symmetry, so this part here must be 6. So D is 6 squared plus 4 squared, which is 36 plus 16, which is 52. Again, that's D squared. I just want D, the square root of 52. Which is 7.21 centimetres. Okay, let's try the next one. This is more your kind of typical exam question with these type of questions. It's very rarely that you'll get given one like the one before, where you get given the triangle exactly as you need it. More often you're given a question like this and you need to find the right angled triangle. Now, whenever you see a question in your exam where you are given a circle and asked to find a length, you are looking for a right-angled triangle because you're aiming to use Pythagoras, okay? And that's your biggest hint I can give you for these kind of questions, is to try and find that right-angled triangle, okay? So if we look at this one here, we want to find the length of chord AB. So we want to find the length of this part here. I know the radius, and it's always a good idea to draw in a radius from the centre to one of the points where you want to find it. So in this case, either B or A. Okay, I want a right-angled triangle. So I'm going to draw that straight down so that I make a right angle here. Now the radius is 5 centimetres. So that line OB is 5 centimetres. The other part I can work out from here is I can work out the length of this part here. Because my radius is 5 centimetres, this distance here is 5 centimetres. Now my full distance is 9.6, so this wee bit here must be 4.6 centimetres. Okay, and then we're just back to using Pythagoras. Can't find the full thing to start with, so we need to find just half of it because that's the part that's in my right-angled triangle. Remember, it must be a right-angled triangle for you to be able to use Pythagoras. Can't use Pythagoras unless you have a right angle. Okay, so we're finding x squared, and it's one of the shorter sides because that points to the longest side, so we're doing 5 squared minus 4.6 squared. Your first mark in these questions comes from identifying the triangle, so make sure you draw it in. So 5 squared minus 4.6 squared. Your second mark comes from knowing to use Pythagoras and what form of Pythagoras to use, whether you're adding or taking away. Third mark usually comes from your answer to Pythagoras, and your fourth mark comes from answering the question. That gave me x squared. I don't want x squared, I want x, so let's take the square root. It's 1.96. That gives me x, not AB. AB is double x, so to get AB, I want to do 1.96 times 2. Which is 3.92 centimetres. Okay, I'll leave you to try it from there.